Yes children, welcome back to Chemistry Wala classes. This is Satish Kumar. In this video, I am going to talk about ions. So first of all, what is the definition of ions? Very simple children. The charged atom, are group of atoms. The charged atom or group of atoms are called ions. So here charge means either positive or negative, but you need to tell what is the meaning of ion. The charged atom or group of atoms are called ions. Ions are classified into two types. Ions are classified into two types. One is cation, second one is anion. So cation meaning is very simple. Positively charged atom or group of atoms is called cation, and anion is nothing but negatively charged atom or group of atoms. So positively charged atom or group of atoms is called cation. Negatively charged atom or group of atoms called anion. But when we go into the deeper concept, so here either cation or anion will be classified into two types again. Simple cations and compound cations. So simple cations, nothing but on the single atom positive charge is present. On the single atom positive charge is present, like Na plus 1, Mg plus 2, Al plus 3. Then what is the meaning of group of or nothing but compound cations? Compound cations, nothing but on the group of atoms positive charge is present. Then what is the example? NH4 plus 1, ammonium cation. Otherwise H3O plus 1, hydroxonium. So these two are the compound cations. At the same time, we have anions also. So classified into two types: simple anions, compound anions. Again same, simple anion is nothing but on the single atom negative charge is present. So single atom with negative charge is called anion. Example, F minus 1, O minus 2, N minus 3. So on the single atom we are getting there minus 1, minus 2, minus 3 charges. So single atom with minus charge is called a simple anion. And compound anions, so on the group of atoms will get a negative charge. Example, NO3 minus 1, CO3 minus 2, PO4 minus 3. So these all are called compound anions because group of atoms with negative charge. And here very important point, that is compound ions, either cation or anion. Compound ions anotherly called polyatomic ions. So this is the classification of anions and cations. But again, the cations are broadly classified into first one, monovalent cation. Monovalent cation, nothing but atoms with plus one charge. The atoms which have plus one charge on them, that all examples are belongs to monovalent cation, like H plus 1, Na plus 1, K plus 1, Cs plus 1, Cu plus 1, at the same time Hg plus 1, Rb plus 1. So these all examples are belongs to monovalent cations because they have plus one charge on them, as well as the valency electrons also one in them. So we can call monovalent means on the atom we need to get plus one charge, and as well as that atom should have one valency electron. So next, divalent cations. So here divalent is nothing but plus 2 charge on the atom, as well as valency electrons. In some metals also valency electrons will get 2. So divalent or bivalent cation examples are beryllium plus 2, magnesium plus 2, and calcium plus 2, strontium plus 2, zinc plus 2, Hg plus 2, Cu plus 2, Mn plus 2, CO plus 2, Sn plus 2, Pb plus 2. So these all examples belongs to divalent or bivalent cations. Next, trivalent cations. Trivalent cations, nothing but the atoms whose valency is 3 are the atoms with plus 3 charge. So Fe plus 3, CO plus 3, Sb plus 3, Al plus 3. So these all atoms belongs to, these all ions belongs to trivalent cations. And next, tetravalent. We have tetravalent cations also. So what are those? So first one is Sn plus 4, Pb plus 4. These two are the good examples for tetravalent. And we have pentavalent also. Pentavalent cations. So one is Sb plus 5, second one is Mn plus 1. These two are the good examples for pentavalent. And T moni, nothing but strontium, and it is manganese. So these are the types of cations: monovalent, bivalent, trivalent, tetravalent, and as well as pentavalent. Next, coming to the point, in the monovalent cation, one example is there, that is ammonium cation, NH4 plus 1. It is compound cation. NH4 plus 1 is called ammonium cation, belongs to monovalent. And next, anions. Anions broadly classified into again monovalent or mononegative. So monovalent anion means the atoms which have minus 1 charge on them, like H minus 1, F minus 1, Cl minus 1, Br minus 1, I minus 1, HCO3 minus 1, NO3 minus 1, NO2 minus 1, and CH3COO minus 1. So these are the best example for monovalent anions. H minus 1 is called hydride, F minus 1 fluoride, Cl minus 1 chloride, Br minus 1 bromide, I minus 1 is called iodide, HCO3 minus 1 bicarbonate, NO3 minus 1 nitrate, NO2 minus 1 nitrite, CH3COO minus 1 is called acetate. Then second one we have bivalent or divalent anions. So on the atom will get minus 2 charge, or on the group of atoms will get minus 2 charge. Example, O minus 2 oxide, S minus 2 sulfide, CO3 minus 2 carbonate, SO4 minus 2 sulfate, SO3 minus 2 sulfite, Cr2O7 minus 2 dichromate, C2O4 minus 2 oxalate, MnO4 minus 2 manganate. So these are the good examples for bivalent anions. Next, third one, trivalent anions. N minus 3 nitride, P minus 3 phosphide, PO4 minus 3 phosphate, PO3 minus 3 phosphite, BO3 minus 3 borate. So these are the good examples for trivalent anions because they have minus 3 charge on them. So very important. So these are the types of cations and anions. By using these cations and anions, will write the formulae of chemical compounds. So how we are going to write few examples, we'll check. The examples are, first one, potassium sulfate. So they will give you chemical compound like this in the exam, so you have to divide the name into two halves. Generally the first half is cation, so you need to remember potassium means K plus 1 and sulfate SO4 minus 2. So K plus 1, write the charge only 1, SO4 minus 2, here minus 2 is there, just write 2 and interchange the charges of ions. You are giving potassium charge to sulfate, sulfate charge to potassium. So this is called interchanging of charges of ions. Then the 2 is going as a subscript to the potassium and the 1 is going as a subscript to the sulfate. But when you get one subscript, you need not to write, so just write SO4 as this. So this is the formula of potassium sulfate. And next you take example of compound ions like ammonium carbonate. So divide the name into two halves. First half generally cation, so it is NH4 plus 1 carbonate CO3 minus 2. So in the ammonium the charge is +1, just you write 1, and in the carbonate the charge is -2, just you write 2. Then you have to interchange the charges. So ammonium NH4 is getting subscript 2, then you take a bracket and write 2, and carbonate CO3 is getting subscript 1, so you no need to take bracket and write 1, just you write CO3, because if you write CO3 and bracket 1 there is no change. Carbons are 1, oxygens are 3, even if you write bracket or if you not write bracket. So ammonium carbonate formula NH4 taken twice CO3. So these are the methods to write chemical formula of the compound by using criss-cross method, because you are interchanging the charges of ions. Then the method is calling here criss-cross method, and the charges on the atom which we are observing are equal to valencies of that atoms. For example, on the sodium +1 is there, so its valency is 1. On the fluorine F -1 is there, so its valency is 1. So here valency is nothing but combining capacity of an atom, combining capacity of an atom to get octet configuration in the valency shell. So just you remember, atoms are losing electrons and forming cation, atoms are gaining electrons and forming anion, just to get octet configuration in the valency shell. So this is about valency. And few d block elements will show variable valencies. So what is the meaning of variable valency or variable valencies? So variable valency is nothing but different combining capacity, different combining capacities of an element. Example, iron show two types of combining capacity. In some compounds iron charge is +2, and in some compounds iron charge is +3. So same metal iron showing different positive charges in different compounds. So iron is having only two different type of positive charges. In that, lowest positive charge is there and highest positive charge is there. So lowest positive charge is called ferrous. So us suffix we are getting when a metal with lowest positive charge. And Fe +3, here the charge is high charge when you compare with +2. So here the name of Fe +3 is ferric. So ic suffix you are getting when a metal is having high positive charge. Same like iron, we have copper, Cu +1, Cuprous, Cu +2, cupric. And next, tin, stannum, we have Sn plus 2, stannous, Sn plus 4, stannic. Next, antimony, stibium, Sb plus 3, antimonous, Sb plus 5, antimonic. Next, Hg plus 1, Hg plus 1 is called mercurous, Hg plus 2 is called mercuric. And next, Pb, Pb plus 2 is called plumbous, Pb plus 4 is called plumbic. So always you are getting us and ic suffix. So metal with lowest positive charge, us suffix, metal with highest positive charge, ic suffix. So you need to remember this to write the formula of the compounds. And here you will get a question. The question is, why these elements have different combining capacity or different charges on them? So the answer is just to form more number of compounds. To form more number of compounds, the D block elements have variable valencies. So how the formulas will be formed, I am going to show you one example. First one, ferrous oxide. So here you can write ferrous, just now I have given Fe plus 2, oxide O minus 2. So here iron charge is 2, oxide charge is 2, 2 cancel, you will get FeO, ferrous oxide. Then second one, ferric oxide, both are not same. So here ferric, Fe plus 3, oxide O minus 2. So plus 3, 3, minus 2, 2, interchange the charges, Fe2O3. So this is called ferric oxide. So iron shows two different positive charges, one is plus 2, another one is plus 3. That is why iron formed two different compounds, one is ferrous oxide, another one is ferric oxide. So like that you have same cuprous chloride, cuprous Cu plus 1, chloride Cl minus 1. So 1 1 plus 1 minus 1 cancel, then you will get CuCl, cuprous chloride. Then cupric chloride, same Cu plus 2, Cl minus 1. Here plus 2, 2 minus 1, 1, interchange the charges. CuCl2 is cupric chloride. Generally in the exam they will write copper 1 chloride, copper 2 chloride. So copper 1 chloride is nothing but cuprous chloride, copper 2 chloride is nothing but cupric chloride. So here the Roman number indicates charge on the metal. And finally I want to tell you a simple information about valency, that is valency is nothing but combining capacity of an atom or element. It is the first definition. Second one, number of electrons lost by metal or number of electrons gained or shared by a non-metal to get octet configuration is called its valency. So we have a rule for metals and non-metals to tell the valency. Metal valency always equal to number of valence electrons in the metal. For example, sodium valency electrons are 1, its valency is 1. Magnesium valency electrons are 2, its valency 2. Aluminium valency electrons are 3, its valency 3. That is why they will show sodium plus 1, magnesium plus 2, aluminium plus 3. And non-metals purpose, non-metal valency is equal to 8 minus number of valence electrons in the non-metal. For example, nitrogen is a non-metal. So nitrogen valency, I want nitrogen valency, that is equal to 8 minus number of valency electrons, nitrogen 1s2, 2s2, 2p3, 5. So answer is 3. Nitrogen valency is 3, that is why nitrogen will show minus 3 charge on it. So this is about cation, anion and types of ions, and valency, which is very important to write the formulas of the chemical compounds. I hope you got it. Thank you.